Before we do example 10, let's take a look at a few things about derivatives. When you take the derivative of e to the x, now remember e is a constant, it's about 2.718, okay? Like pi is 3.14, e is about 2.718. So we've got the base is this constant, e, and when you take the derivative, you just get e to the x. When you take the derivative of e to the function f of x, you have to use the chain rule and do e to the f of x times f prime of x. Now, let's look at what happens when you have a base other than e. So here I have f of x equals a to the x. Then the derivative of that, similar to this e to the x, in that you copy the base, but you have to multiply that also by the natural log of the base. And if it's raised to a function power, something that you can take the derivative of, it's very similar to this. It's you copy the base to the function exponent, then you take the derivative of that, there's your chain rule, but don't forget you also have to have a natural log of a in there. And you can do this in any order, it doesn't matter. Right? You just want to make sure nothing ends up under that natural log except for that base. That's why I like to put it at the end. So we're going to go backwards now, and we're going to take the integral of something that looks similar to this. We're going to take the integral of a to the x. So since we multiplied by the natural log of a, up here we have to divide by the natural log of a to take the integral. And of course, always plus c. And if that's a differentiable function in your exponent, you copy it and you have to divide by these things that we multiplied by. And then, of course, plus c. Okay, so let's use this to do example 10. Evaluate the integral of 11 to the x dx. Now notice that our exponent is x and the derivative of x is 1. So we copy the base to the exponent. We divide that by the derivative of the exponent and the natural log of a. Since our exponent is an x, the derivative of that's a 1. So we really don't have to do that. So the integral of 11 to the x dx, let's copy the base to the power, divide that by, well, that would be a 1 for the derivative, and then the natural log of 11 plus c. And of course, I can finish that off by saying 11 to the x over the natural log of 11 plus c. And that is my final answer.